Hi, Mr. Wright here, and welcome to this film in which I'll walk you through 10 more real Grade 9 IGCSE Maths questions. Now, you can download the questions by hitting the link in the description and then have a go at the questions before you watch the film, or of course, you can watch the film as you work on the questions and work alongside me. Now, don't worry if you find these questions tricky, they're supposed to stretch you. Try each question first, and if you're thinking, I don't know how to make a start on this, then work out anything you can work out. That will probably lead you towards a solution. And even if it doesn't, you'll score those vital part marks anyway. Now, let's have a look and see what we've got coming up. Probability, indices, sequences, circle theorems, a problem involving a cone, transforming graphs, coordinate geometry, 3D trig, another coordinate geometry question, and a problem involving a hemisphere and a cylinder. So lots of typical, traditional grade 9 stuff. While you're watching the film, if you want to ask a question, please do ask a question by leaving it in the comments, and of course I'll respond. And if you're finding the film useful, well, hit like. Leave me a comment and tell me so. I read all the comments and I will get back to you with anything I can do to help you further. And while we're here, why not have a look at my grade 7, 8 and 9 practice papers? You can scan the QR code there and find out all about those. If you're finding these questions useful, if you're finding these questions brutal, then there's all the more reason to have a look at these practice papers. Right, let's get on with the maths. Right, here's question 1. Now, this question starts off relatively simply, but there is a twist. You have to be very careful about dependent events. I imagine you've seen that already. Let's have a look. Now, the bowl contains n pieces of fruit, and of these, 4 are oranges, and the rest are apples. So I have got oranges, 4, apples. How many apples? N minus 4 apples. Gives me n pieces of fruit altogether. 2 pieces of fruit are going to be taken at random from the bowl. The probability that the bowl will then contain n minus 6 apples is a third. Work out the value of n. Well, if after 2 pieces of fruit have been taken out, there are now n minus 6 apples, and if we started with n minus 4 apples, then both the pieces of fruit taken must have been apples. So when it says the probability that the bowl will then contain n minus 6 apples is a third, what it really means is that the probability of choosing an apple followed by an apple is a third. And that's where our equation is going to come from. Now, when we come up to the bowl to take the first piece of fruit, there are n minus 4 apples out of the n pieces of fruit. So the probability of the first one being an apple is n minus 4. And what about when we come up to the fruit bowl for a second time? Well, there aren't n minus 4 apples anymore. There's one fewer. So there'll be n minus 5 apples. And there won't be n pieces of fruit because we've already taken out an apple. So there'll be only n minus 1 pieces of fruit. And that's what equals a third. And now we're left with this equation to solve for n. Now, very often in these questions, you end up solving an equation that looks something like this one. Let's look at that fraction on the left, and let's do top times top and bottom times bottom, because I'm multiplying those 2 fractions together. And that's what equals a third. Now, I call this cross multiplying. When you've got a fraction equals a fraction, you can simply cross multiply. What I mean is I'm going to multiply both sides by 3. So I'm going to end up with 3 multiplied by the numerator here. And at the same time, I'm going to multiply both sides by the denominator on the left by n lots of n minus 1. So I'm going to end up with n lots of n minus 1 multiplied by the numerator on the right. And now this equation is starting to look a bit simpler. I've got 3 lots of n squared minus 4n minus 5n minus 9n plus 20 equals n squared minus n. Keep on going. 3n squared minus 27n plus 60 equals n squared minus n. Looks like it's going to be a quadratic equation. Let's set it equal to 0. Let's subtract an n squared from both sides and add an n to both sides. Be careful, that leaves you with minus 26n. Copy down the plus 60, and that equals 0. Now I have to solve this quadratic equation. I can either use the formula, or I can look to factorize. Well, the first thing I'm going to do is divide left and right by 2. And now I'm thinking that I'll probably be able to factorize this. N and n, multiply to positive, but add to a negative. Look at that, it's 10 and 3, isn't it? So my solution here is that either n is 10 or 3. Now, before we finish off, let's look back at the question. The question says, work out the value of n singular. So clearly, either 10 or 3 are not. One of them is going to be an impossible answer. If you look at the top here, do you see how it says 4 of the pieces of fruit are oranges? Well, in that case, the number of pieces of fruit in the bowl can't possibly be 3. So the only answer which is valid is that n equals 10. And that is question 1 complete. Right, let's go and have a look at question 2. Here we go. Have a quick look. What are you thinking? Now, I'm thinking that this question is all about indices, and it's going to be all about writing things in the same base. And I can see I've got base 2 and base 5. That 10 could be written in base 2 in terms of 2s and 5s, and so could the 20. So I think we're going to have to start thinking along those lines. So looking at the numerator here, I have got 10 to the power of 4n times 2 to the power of 3 lots of n squared minus 5n times 5 to the power of 2 lots of 1 minus 2n over 20 squared equals 1. Find the values of n, so that equation holds. Let's have a look at that numerator then. I've got 10 to the power of 4n, so that's going to be 2 times 5 to the power of 4n times 2 to the power of, I think I'll multiply out that bracket, 3n squared minus 15n times 5 to the power of, let's multiply out that bracket, 2 minus 4n. And all of that equals all of that over 20 squared equals 1. So 20, 2 times 2 times 5 squared. And all that has to equal 1. Okay, shall I keep on going? Now, I can simplify this. That is 2 to the power of 4n times 5 to the power of 4n times 2 to the power of 3n squared minus 15n. Notice how I'm only doing one thing at a time. Now, all of that is over 2 squared times 2 squared times 5 squared. And that equals 1. So on the numerator here then, I've got 2 to the power of 4n times 2 to the power of that. Well, I can simply add those indices. So that's going to be 2 to the power of 3n squared minus 11n times 5 to the power of 4n times 5 to the power of 2 minus 4n. Add those indices, 5 squared, divided by 2 to the power of 4. Happy with that? I'll just simplify 2 squared times 2 squared. times 5 squared, and that equals 1. Now, I've got the numerator divided by the denominator. So I'm going to subtract the indices. So I'm going to have 2 to the power of this divided by 2 to the power of that. So it's going to be 2 to the power of this minus that. 2 to the power of 3n squared minus 11n minus 4 times by, I've got 5 to the power of that minus 5 to the power of that. 5 to the minus, 5 to the power of 2 divided by 5 to the power of 2. It's just 1, isn't it? 5 to the power of 0 times 1 equals 1. Now that gives me 2 to the power of this equals 1. Well, 2 to the power of 0 is 1. So this power of 2, 3n squared minus 11n minus 4, must equal 0. So there's a quadratic equation for me to solve. Now, before we press on, let's just have a look at this. I notice it says find the values of n. So I'm quite reassured I've got a quadratic equation here, because that will give me 2 solutions. I'm going to try factorising it first. I don't know if this will work, but if it doesn't, then I will use the formula. I know that both of them are going to be, they're not going to both going to be negative at all. They multiply to a negative, so one's plus and one's minus. I'm multiplying to 4, aren't I? I'm thinking about 2 and 2, that's not going to work. I'm thinking about 4 and 1. If I put 4 here, then I end up with 12. So minus 4 gives me minus 12, plus 1 there. There you are, that's going to work. So my solutions for n equals minus a third or 4. Now, have I finished that now? Find the values of n such that that is true. Yes, I have. And there is my solution for question number 2. Not bad at all, but you did have to be confident in your rules of indices. Now, let's move on and see what we've got. Question 3, sequences. Now, this is a pretty classic grade 9 question. We're going to need to write a couple of equations and solve them simultaneously, and only then will we be able to answer the question. Only then will we be able to find the value of n. So how can we get a couple of equations from this wording here? Let's have a look. First of all, the sum of the first n terms in an arithmetic sequence is that. So I'm going to instantly write down sum of the first n terms, which, by the way, we know the formula because it's at the front of the paper. The sum of the first n terms is 292. There we go. I've written down that red piece of information. Now, the second term is 8.5. So I can straight away write down that a plus 1 difference is 8.5. And the fifth term is 13. So I can straight away write down a plus 4 differences equals 13. Now I'm thinking I can solve these 2 equations simultaneously to find a and d. Let's carry on and read the question. Find the value of n. Well, what was the value of n? Oh, the value of n comes from here, doesn't it? The sum of the first n terms is that. Let's leave that red equation for now. And let's just get on and do what we can. What I can do is I can solve these 2 green equations simultaneously to find a and d. I'm going to do the bottom one minus the top. So 3d equals 13 minus 8.5. 4.5. So d equals 3 over 2, or 1.5. So now I can find out what a is, because I know from the first equation that a plus d equals 8.5. So a plus 3 over 2 equals 8.5. So that means that a will equal 8.5 minus 1.5. A will equal 7. So now I know all about this sequence. I know that its first term is 7, and the differences between the terms is 1.5. Okay, let's go back to what we were told in red here. The sum of the first n terms is 292. That's what allowed me to write this equation. And I need to find out what that n is. But you see, now I can rewrite that equation n over 2 times my, instead of 2a, I can write 2 times 7 because I know the first term, plus n minus 1, still don't know what that is, but I do know that d is 3 over 2, and I know that has to equal 292. So here's an equation which I can solve for n. Right. I'm going to double left and right, I think. So that's going to give me just n here. And instead of 292, it's going to give me 292 times 2, 584. Now in the bracket, I've got 2 7s, 14, plus 3 over 2n minus 3 over 2. Okay, so what have I got here? Let's tidy up the bracket, shall we? 14 minus 1.5 is 12.5, plus 3 over 2n equals 584. Multiply out that bracket. 12.5n squared, sorry, 12.5n plus 3 over 2n squared equals 584. So I'm tempted to multiply everything by 2, really. Get rid of that 2 on the bottom. And while I'm at it, I'll write my n squareds first. 584 multiplied by 2. Now, I've got a quadratic equation now. I'll set it equal to 0. And I need to solve it for n. Now, do I really fancy factorising that? Probably not, to be honest. So let's use the formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be minus 25 plus or minus the square root of 25 squared minus 4 times 3 times minus 1168 all over 6. And now, carefully, I'm just going to put that straight into my calculator. I'm going to use the fraction function, minus 25 plus first, square root. 25 squared minus 4 times 3 times minus 1168. And then on my numerator, 2 times 3 is 6. That gives me 16, or now I can go back and edit that plus the square root to minus the square root, minus 73 over 3. Now, that means that n is either 16 or minus 73 over 3. Well, given that n is the number of terms, the sum of the first n terms is 292, I'm thinking that the only reasonable answer here is that n equals 16. Now, have we answered the question? Find the value of n. Yes, we have. I've called it little n rather than capital N, but I'm sure you'll forgive me that. And that is question 3 complete. Now, let's see what we've got coming up for question 4. By the way, finding this film useful? Please hit like. It really helps the channel. Leave me a comment. Tell me you're finding it useful. Or, of course, if you've got a question, then leave it in the comments, and of course, I'll respond. Question 4, circle theorems. Let's look at that. What are we thinking? We haven't read the question yet, but which circle theorems might come into play? Well, I can see a cyclic quadrilateral. That's helpful. Might be helpful. I can see an isosceles, or I can see two sides the same length. That might be helpful. What else can I see? There's a tangent. Now, which circle theorems would that be? Obviously, the angle between a radius and a tangent is 90, but I ain't got a tangent, a radius there. The other circle theorem we often use with a tangent is the alternate segment theorem. So I think about that. Could we use that theorem there? I'm not sure. Let's have a look. Thinking about that tangent and thinking about the alternate segment theorem, I'm thinking that we could add a line so that we can use the alternate segment theorem. The line I'm thinking of adding is this one here. We better read the question, really. A, B, C, and D are points on a circle. PCQ is a tangent, yes. AB equals CB, yes, that's marked. Angle BCQ equals X, yes, that's marked. Prove that CDA, that's this one, equals 2x. So that is the target angle there. We have to prove that that equals 2x. Look out, give reasons for each stage in your working. Right, what are we thinking? Well, I'm thinking, and by the way, if you're stuck on this, find out what you can. Work out what you can. It might lead you to the answer. The first thing I'm thinking here is that there's a tangent, so I'm thinking about the alternate segment theorem. I'm putting my windsurfer here, pointing at his feet, pointing at the angle up there. So the alternate segment theorem tells me that this angle is also equal to x. Now remember, you have to give reasons for each stage of your working. So I'm going to say CAB equals x equals BCQ, say y, alternate segment theorem. You should probably write those out in full. Okay. Now just a minute. That's an isosceles triangle, isn't it? So isn't it the case that this angle is also x? Yes, it is. Let's write that one down. ACB equals x, y, because it equals CAB, because triangle ABC is isosceles. Good. Now, can we continue to use that triangle for a moment to find angle B? Angle ABC. Angle ABC. Well, there are 180 degrees in a triangle, aren't there? So it's going to be 180 minus x, which is 180 minus 2x. Why? 180 degrees in triangle ABC. Okay. So what we've discovered is that this angle here is 2x. Okay. No, we haven't. I beg your pardon. What we've discovered is that angle is 180 minus 2x. That's what we found it to be. My mistake. Now, we've got a cyclic quadrilateral, haven't we? So we know that opposite angles in a cyclic quadrilateral are equal to 180, add to 180. So I think now we can move towards our target angle. CDA is going to be 180 minus ADC. Why is that? Opposite angles, you have to write this out in full, in a cyclic quadrilateral add to 180. Right, let's carry on with that. 180 minus ADC. Remember your brackets, minus 180 minus 2x, that's what ADC is. 180 minus 180 plus 2x. Look at that. CDA is equal to 2x as required. And there is my question 4 complete. Prove that angle CDA equals 2x. Give reasons for each stage in your working. Right, let's have a look at question 5. Here it is. A problem to do with a cone. Now, we're going to need to derive quite a complicated equation in this question using this piece of information that we're given here. Have a go and come back to me. Okay, so we've got a cone and we need to remember that we've got some formulas to help us on the formula sheet, which I've copied just here. We're told that AB is the diameter of the cone. Well, it does look like that on the diagram, and that V is the vertex. Again, it looks like that. Given that, the area of the base of the cone, the ratio of the area of the base of the cone to the total surface area of the cone equals 3 to 8. I think that's going to give us an equation, isn't it? Work out the size of angle AVB. Well, I kind of think working out that size of the angle is probably secondary for now. Let's concentrate on what we can do, and we can use that ratio fact to give us an equation, I think. Let's have a look. The area of the base of the cone. Well, the base of the cone is a circle, right? And if I call the radius of the cone r, then the area of the base is simply pi r squared. So the ratio of that to the total surface area of the cone. So the ratio pi r squared to the total surface area of the cone. Now, what's the total surface area of the cone going to be? Well, I guess we'll stick to calling this L and R. So the total surface area of the cone is going to be the curved surface area, which is pi r L, and the area of the base, pi r squared. And we know that that ratio is 3 to 8. So that means that 3 times the black, 3 times the larger, equals 8 times the smaller. Okay. All right, let's see what happens, shall we? So I've got 8 pi r squared equals 3 pi r L plus 3 pi r squared. Well, I could take 3 pi r squared off both sides, couldn't I? So now I've got 5 pi r squared equals 3 pi r L. I could divide both sides by pi and by r. So if I divide both sides by pi and by r, then I have 5r there equals 3l. Oh, well, now I know that the slopey length there, the L, is 5/3 times the radius. Okay. All right. Let's have a think now about the question that we're asked. Work out the size of angle AVB. Let's have a look at AVB. A to V to B, we're being asked for that angle. I think I'm inclined to work with right angle triangles to start with, see if we can do something with this triangle, maybe. So should we have a look at that? We've got from V, come down to the midpoint there, come along to A, and then back up to V. Now I know that that is 5/3 r, great, and I know that's the radius, of course. Now can I find this angle? What shall I call it, alpha? I don't see why I shouldn't be able to find it. Let's have a look, shall we? We are going to be dealing with sine, aren't we? So sine alpha is the opposite over the adjacent. Well, look at that. The r's cancel straight away. 1 over 5/3, the reciprocal of 5/3. Sine alpha is 3/5. So I'm thinking I can find alpha now. Shift sine, 3/5. Shift sine, 0.6, close the bracket, means that alpha is 36.869 and so on. And so the angle that we're asked to find, AVB, will be twice that. Twice alpha equals, I've got alpha on my calculator, times by 2 equals 73.739. 1 decimal place, 73.7. Now, what does that question teach us about tackling these grade 9 questions? Well, keep calm and carry on would be one thing, because when we were here, we were maybe thinking, where is this going? But we had to just keep calm and carry on. What else does it teach us? Well, don't try and answer the whole question all at once. Stick with what you're given and work it through. Okay, so there are 2 lessons from that one. Okay, let's move on. Aha, a reminder. If you're finding these questions challenging, if you want more of the same, if you want to get that top grade and you want to get more practice under your belt, have a look, find out about my grade 7 to 9 practice papers. 57 grade 7 to 9 type questions. I've written them all myself, and the questions cover 24 grade 7 to 9 topics. Okay, enough of that. Let's have a look at question 6, transforming graphs. Now, transforming graphs is always tricky. It's easy to lose marks, especially when multiple transformations are involved. You need to be looking at part A and working it through step by step. And part B, well, that depends on some complex algebra and on your understanding of graph transformations. Let's have a look. Now, we're given the graph of y equals sine of x, and we're asked to draw the graph of y equals 2 sine of x plus 30. So we've got two transformations here. The first one is caused by this 2 outside the bracket. Now remember, if it's outside the bracket, it affects the y coordinate. So the x coordinates will remain the same and the y coordinate will double. So 0, 0 will remain at 0, 0. But 91 will go to 92. 90, 2. 180 will remain 180, 0 because double 0 is 0. 270 minus 1 will make its way to 270 minus 2. And that will remain there. So drawn in blue now, oops, not very well, try again. Drawn in blue here is the graph of y equals 2 sine x. Now, let's have a think about this second change. This is a change in the bracket. It's going to affect the x-coordinate. So the y-coordinates will remain the same, and the x-coordinate is going to be affected. Is it going to have 30 added to it? No, because those changes happen in reverse, don't they? So the x-coordinates are going to have 30 subtracted from them. That blue graph is going to be translated by 30 units to the left. So this point here is going to be moved, going to be translated 30 units to the left. So it's going to come here. This point here, 30 units to the left. This point here, 30 units to the left. This point here, 30 units to the left. So what is the new graph going to look like? Well, it's going to look like this. Smooth through that. Okay, and that is my answer. The red graph is my sketch of the graph y equals 2 sine of x plus 30. Now let's have a look at part B, shall we? Part B, part 1, is some, well, straightforward, routine algebra. We need to complete the square on x squared minus 6x plus 10. So here we go. X squared minus 3x. Sorry, I'm going to start again, give myself a thinner pen. Right, I've got x squared minus 6x plus 10. So that's going to be x minus 3 squared minus 9 plus 10. So that's going to be x minus 3 squared plus 1. Just having a check, just checking I'm happy with that. Yes, I am. Hence, describe fully the single transformation that maps the curve y equals x squared onto the curve y equals x minus 3 squared plus 1. Now, what's going to happen to the curve as I go from there to there? Well, the first thing I notice is the change outside the bracket. That's going to add 1 to each of the y coordinates, isn't it? So that's going to translate the curve by 1 unit up. And then I notice the change in the bracket. That's going to translate the curve in a horizontal direction. Is it going to send it 3 to the left? No, it's going to send it 3 to the right. So the single transformation is going to be a translation by the vector. What did it do? It went 3 to the right and 1 up by the vector 3, 1. That is question 6 sorted. Finding this film useful? Go on, hit like. Got a question to ask? Ask me in the comments, and of course I'll help you out. Or just make a comment. Tell me how you're finding the film. Question 7. P and Q are 2 points. There are the coordinates. Find an equation of the perpendicular bisector of PQ. Now, if you're thinking, oh, I know how to do that, and I can do it automatically like a robot, then that's great. If you're not, then perhaps a sketch will help you out. If in doubt, draw it out. Let's have a look. Coordinates of P are -1, 6. And the coordinates of Q are 5, -4. Let's draw a sketch of an axis here. Okay, it's only a sketch. It doesn't have to be accurate. It's just going to give me the idea. P, -1, 6. Q, 5, -4. Q. PQ. And we're asked to find an equation for the perpendicular bisector. So 2 things. It's going to bisect the line PQ, so it has to be going through the midpoint of P and Q. And it has to be perpendicular to PQ. So I have no idea where it's going to go. Roughly, it's going to go there, isn't it? Where that's the midpoint and that's a right angle. Okay, good. So I'm thinking 2 things, because we have to find an equation for that red line. Now, to find an equation for a line, we need to know 2 things. We need to know a point on the line. We also need to know the gradient of the line. Now, I know a point on the red line because it goes through the midpoint of PQ. Now, P and Q. Here we are. P, -1, 6. And Q, 5, -4. So the midpoint, -1 plus 5 divided by 2. 2, the average of the 2x coordinates, and the average of the 2y coordinates. 6 and -4 is 2, divided by 2 is 1. So the midpoint is 2, 1. So I do know a point on the red line. The red line goes through the point 2, 1. Now, what about the gradient of the red line? I don't know. But I do know the gradient of the blue line, or at least I can work it out. If I know the gradient of the blue line, then I can work out the gradient of the red because they're perpendicular. So let's have a look at PQ and let's work out its gradient. Now, you could always draw a right angle triangle here, and you could have a think about rise over run, or you could use the coordinates themselves. Have a think about rise over run. Let's have a look. I'm going to go from P to Q. Now, my rise is from 6 goes down to -4. So my rise is -10, and my run is from -1 to 5, 6. So my gradient here is -5/3, which means that the gradient of the bisector is the negative reciprocal of that. So it's not going to be -5/3, it's going to be 3/5. Now I know the gradient, and I know a point on the line. So here is a standard method to find the equation of that red line, the equation of the perpendicular bisector. We know that y equals mx plus c, so we know that y equals the gradient 3/5 of x plus c. And now we can use the point we know. We know our red line goes to the point 2, 1. So when x is 2, y is 1. So let's substitute those values in. 1 equals 3/5 times 2 plus c. Now we can discover what c equals. 1 equals 6/5 plus c. Subtract 6/5 from both sides. C equals -1/5. Okay, now I know that my equation is y equals 3/5 of x. It was plus c, so now it's -1/5. Have I done it? Let's have a look at the question. Find an equation of the perpendicular bisector at PQ. Done. Give your answer in the form something x plus something y plus c equals 0, where a, b, and c are integers. So I need to have everything on the left, and I need a, b, and c to be integers. So I'm going to multiply everything by 5. And now I've got integers there. So I'm going to subtract. Now let's just have a look at the form. Something x. So I'm going to subtract 3x from both sides. There's my 5y's. Add 1 to both sides, and there is my answer. Alternatively, you might have had the answer 3x minus 5y minus 1 equals 0. And that would be fine too. And I'm thinking that that is question 7 done. What's been your favourite topic so far? Let me know in the comments. Or, if you'd like me to produce a film with more of any particular topic in it, let me know. What topic would you like more practice in? Question 8. 3D trig. Now, perhaps 3D Pythagoras as well. Who knows? Okay, we're going to have a think about this one. We know it's a tough question. It was a question 22. We're going to need to visualize everything carefully, and it might help if we write out or draw out the right angle triangles that we're using in 2 dimensions so we can see their dimensions clearly. So let's give it a shot. We've got a triangular prism with a horizontal base. We've got several sides which are all equal to 12, and that's as they look on the diagram. AB is labelled on the diagram, BE is labelled on the diagram. Calculate the size of the angle between AD and the base. Now, this can cause confusion sometimes. Sometimes people think, what angle is it that they're asking us to find? Let's draw the line AD. And we've got to find the angle between that line and the base of the shape. So do we find that angle, this angle, or what? Well, the answer is that you have to imagine the shadow of that line AD. And where would that shadow come to answer? It would come vertically below the point D. So the angle that we're being asked to find is an angle in that right angled triangle there, and it's the angle alpha. Now let's start by drawing out that 3-dimensional triangle in 2 dimensions so we can see it clearly. We've got a right angle there, D, shall I call that, let's call that X, shall we? DXA, there's the hypotenuse, that's the angle alpha, that's our target angle. Now what do we know about this triangle here? Well, precious little at the moment, I think. I'm wondering if we could find this length, the length of dx. Because I'm thinking, if I can find the length of dx, and I can find the length of ax, then I might be able to use tan to find the angle alpha. So let's have a look at that, shall we? And by the way, if you hadn't seen your way through to that method, then you could simply have a look at that red triangle that we've drawn out at the bottom and ask yourself, okay, what can I find? And see what you can calculate. Now I'm going to have a look at this triangle here, the triangle DEX. Let's have a look. It's the triangle at the back of the shape. D to E to X. DEX. That's 12. Now, X to E is 5. It's half of the width. And now I'm thinking that I can find this side, the side dx, using Pythagoras. So dx, which I've labelled x, will be the square root of 12 squared minus 5 squared. Right. Square root 144 minus 25 equals the square root of 119. Now I could work out what that is, but I don't think there's much point really. I might as well just call it the square root of 119. Now, it would also be nice to be able to find the length from A to X. Which length do I mean? I mean this length here, this length here. Right, let's have a look at that. Let's have a look at the base of the prism. The base of the prism is a rectangle, isn't it? So let's draw the rectangle, which is the base of the prism. Okay. Here we are. That is FEBA. And my line from A to X goes from A to X. Now, what lengths dimensions do I know on that? Well, I know that EB is 15, so I'm guessing, well, I'm not guessing, so that's also 15. That whole length is 10, so that's 5. Now, just a minute. Haven't I got a right angle triangle here? So can't I use that to find the length of AX? Let's call AX Y. Y squared will be 5 squared plus 15 squared. So Y will be the square root of 15 squared plus 5 squared. 5 root 10. Okay, so now I know this dimension here. A to X is 5 root 10. So I'm having... my method is working, isn't it? Because now I can look at this right angle triangle here, and I can say tan alpha equals the opposite, square root of 119 over the adjacent 5 times root 10. So on my calculator, fraction function, square root of 119 over 5 times square root of 10 equals, and then I'm going to use shift term equals to give me alpha. Shift term equals 34.602 and so on. Now, calculate the size of the angle between AD and the base. Give your answer correct to 3 significant figures. 34.6 degrees. And that is that question sorted on 3D Trig and 3D Pythagoras. Okay, happy with that. Let's have a look at question 9. Aha, we're switching, just indeed as your papers will switch, won't they? Now a question on coordinate geometry. What have we got here? We've got a curve with an equation and a straight line with an equation, and they intersect. A bit of algebra there, perhaps, to find the points of intersection. Work out the exact length of AB. Okay, so I'm thinking, what can we find? Can we find those points A and B, where the curve and the line intersect? And then can we work out the exact length? Let's worry about one thing at a time when we solve this question. So, points of intersection. Well, to find the points of intersection of two curves, I'm going to need to solve them simultaneously. I'm going to need to find the values of x and y, which satisfy both equations. The values of x and y, which lie on both of the lines or curves. So I've got the green one there, and I've got the red one here. Now, I'm used to solving these quadratic simultaneous equations, but often they're not hidden in a coordinate geometry question. But I'm going to follow my nose and solve them in the normal way. Let's rearrange this to make x the subject, adding y to both sides. And now let's substitute in y minus 4 into the green equation in the place of x. So we're going to have x squared, i.e. y minus 4 squared, minus x, careful with your bracket, plus y squared equals 10. And now, having substituted y minus 4 in the green equation in place of x, I've got an equation which has just got y's. Okay, so I can solve this for y. I'm going to write that out like that because I definitely don't want to make a mistake. Okay, so let's expand those brackets, shall we? Y squared minus 4y minus 4y minus 8y plus 16. Let's remove this bracket. Minus y plus 4 plus y squared equals 10. Try and keep your discipline. Try and do one thing at once. Tidy up your y squareds, 2y squareds. Tidy up your y's. Minus 8 minus 1 is minus 9y. Numbers, plus 6 plus 4 plus 20 equals 10. Quadratic equation, set it equal to 0. 2y squared minus 9y plus 10. I'm minusing 10 from both sides, equals 0. I've got to solve this quadratic equation to give me two values for y. Should we try factorising? 2y, y equals 0. We know it's minus minus because they multiply to a plus and give me minus 9y. 10, so 2 and 5 maybe? 1, 2, and I see 2 and 5. Look, 2 there and 5 there, because then I get minus 5y and minus 4y. Gives me my minus 9y. So y will be 5 over 2 or 2. So those are the y coordinates of my points of intersection, the y coordinates of A and the y coordinate of B. So now I'm going to use this equation here. X equals y minus 4. So if y equals 5 over 2, x will be 5 over 2 minus 4. 2.5 minus 4 is minus 1.5. And if y equals 2, then x will be 2 minus 4 minus 2. So this first point of intersection has an x coordinate of minus 3 over 2 and a y coordinate of 5 over 2. And the second point of intersection has an x-coordinate of minus 2 and a y-coordinate of 2. Let's go back to the question and just take a breath. The curve with this equation and the straight line with that equation intersect at points A and B. Work out the exact length of A and B. Okay, so I've got A and I've got B. I don't think it matters which way around they are. The exact length of A and B. Right. So can you remember how to work out the length between 2 points, the distance between 2 points? I can, as it happens, but let's imagine that we are wondering what to do. So if in doubt, draw it out. Here we go. Now A is at minus 1.5. Put it here, shall I? Minus 1.5, 2.5. That's the point A. B is at minus 2, 2. And there's the distance AB. Right. Let's use a right angle triangle, shall we? Here's my distance AB. I'll call that X. Actually, no, I won't, because I've got X coordinates and all sorts. So let's just call that AB, shall we? AB. So AB squared is going to be, now what's that length there? It's a half, isn't it? A half squared plus a half squared. AB squared equals, so that's a quarter plus a quarter. Come on, Chris. What's going on here? Try again. So AB will be the square root of a half. Okay. Have a look at the question. Work out the exact length of AB, show your working, and give your answer in the form root A over 2, where A is an integer. So I've got my answer is the square root of a half, and it's asking me to give that in the form root A over 2, where A is an integer. Well, I'm just going to rather cheekily put in my calculator the square root of a half and press equals. And it tells me that that is root 2 over 2. So I have used my calculator to get my answer and put it in the form that they want. But I guess that you're curious and you would like to know how that works. So this is how it works. Or perhaps you're ahead of me, of course. AB is the square root of a half. Fine. So the square root of a half is the square root of 1 over the square root of 2. Okay, well the square root of 1 is 1, right? So that's 1 over root 2. Now if I multiply top and bottom by root 2, then I get root 2 on the top, and root 2 times root 2 is 2 on the bottom. So that is how you can go from the square root of a half to the answer in the form that they wanted. But of course, you can simply use your calculator. And that Is that question 9 done? Rather complicated. Lots of steps. First of all, we had to find the point of intersection, the points of intersection. Then we had to find the length between the 2 points. And then we had to give our answer in the form that they asked for it in. So, quite a complicated question there. Question 9 done. Now let's have a look at question 10. The last one. Right, now this is pretty brutal. I know it says question 21. Sometimes those questions, the penultimate question and the one before the penultimate question, I think are the hardest ones on the paper. Now, I can see a hemisphere, I can see a cylinder. I'm thinking it might be about volumes, it might be about surface areas. Okay, and I'm thinking that this line here, the ratio of the, let me just spread that background, the ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. That might be useful. And look at this. Given that the solid has a volume of that. So I'm thinking perhaps we need to work out an expression for the volume of that solid and use that, put that equal to 792 pi. One thing's certain, we're going to need the formulas from the front of the paper. And as if by magic, here are those formulas. Right, let's have a look at this question properly. A solid is made from a hemisphere, half a sphere, and a cylinder. Just have a quick look, make sure that you can visualize that. The plane face of the hemisphere, well, that's the flat face of the hemisphere. That's the circle on the bottom there, coincides with the upper plane face of the cylinder. What they're saying is that the two shapes meet perfectly. The hemisphere and the cylinder have the same radius. Well, they kind of looks like they do, don't they? So there's the radius here, and here's the radius here. Okay, and the radius of the cylinder and the radius of the hemisphere are kind of the same. Fine. The ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. Here's a cylinder. The ratio of the radius to the height is 1 to 3. Wait a minute. That means that the height equals 3 times the radius. H equals 3r. So suddenly, look at that. I can label the height of my cylinder. The ratio of the radius of the cylinder, the height of the cylinder is 1 to 3. Right, so if the radius is r, then the height is 3r. Good. Given that the solid has a volume of 792 pi, work out the height of the solid. So the volume of this solid equals 792 pi. So this is urging us to come up with an expression for the volume of the solid and set it equal to 792 pi. To translate this sentence into maths, the solid has a volume of 792 pi. Let's do that. So the volume of the solid, well, it's a cylinder, isn't it, with a hemisphere on top. Volume of the cylinder, pi r squared h, plus volume of the hemisphere. Now be careful, this is the volume of a sphere, and we've just got half of that, haven't we? So it's not going to be 4/3 pi r cubed, it's going to be 2/3 pi r cubed, and that is going to equal 792 pi. Now steady as she goes, one thing at a time. Do you notice how I've written h here, but we know that h equals 3r. Okay, so what we're going to have here is pi r squared times 3r plus 2/3 pi r cubed equals 792 pi. Right, let's deal with this bit. Notice how I'm taking it steady. I'm doing one thing at a time. 3 pi r cubed. Try and resist jumping steps because it is a surefire way of making a foolish error, or I should say an avoidable error, perhaps. What shall I do now? I'm going to multiply everything by 3. Get rid of that 3 on the bottom. 9 pi r cubed plus 2 pi r cubed equals 3 times 792. 3 times 792, 2376 pi. Just on the left there, I've got 11 pi r cubed, haven't I? equals 2376 pi. Divide both sides by pi. 11r cubed equals 2376. Divide both sides by 11. R cubed 2376 divided by 11 equals 216. Cube root both sides. R equals the cube root of 216. 6. So the radius is 6. Brilliant. Now, let's go back to the question. Be careful. The ratio of fine. Given that the solid has a volume of that, work out the height of the solid. Now, the height of the solid, is that this height? Which, by the way, is 3r. 3 times 6 is 18. No, it's this height. So it's going to be the 18 plus another radius. So the height of the solid, in answer to the question, the height of the solid is 4 times 6, 24. And that is the final question on this set of 10 grade 9 questions. So quite a lot going on there, quite a lot to decipher, and quite a lot of algebra. It'd be easy to fall into a trap there. Take things steady, one step at a time. Well, there you have it. Well done for sticking with me through those challenging grade 9 questions. Now, if you found this film helpful, please hit like and leave a comment too. Tell me which topics you would like more practice on. Tell me which questions you found difficult. Tell me how you found the film. If you're looking for more practice, then check out my grade 7 to 9 practice papers. 59 IGCSE type questions, all pitched at grade 7, 8 and 9, covering 24 grade 7 to 9 topics. Thanks for watching. See you in the next film.